Okay, I'm going to attempt to make a video on scatter plots, correlation, and regression lines. Fair warning, my sweet Winnie June, that's the dog, she is in rare form right now, so this may be interrupted. Okay, so the last section, which is sort of sad because ordinarily we would have been together, but Hurricane Helene had other plans. But the last section of this course is on scatter plots, correlation, and regression. So let's talk first about a scatter plot. So a scatter plot is a collection of data points where you have one data point per object or person. However, the data points are created from two data items. Okay, so think quite literally points in the Cartesian plane. If you're going to go and plot a point in a Cartesian plane, you need an x coordinate and a y coordinate. So each data point is made of two data items, or think two variables. All right. And each of these two variables makes one data point, and there's one data point per person or object in your data set. So some examples could be your age and then your corresponding blood pressure. Another one that I've seen frequently is time spent studying. And a corresponding grade. I thought my dog was drinking out of the toilet. She wasn't. We're good. All right. And then a third one that you'll see would be something like the weight of a food item. And here she is. Weight of a food item and corresponding calories. This is just 3 examples, okay? So again, for each data item, it's going to be made up of two pieces of information. So think like an x coordinate and a y coordinate. And then there's one of these data points per person or object in your data set. Okay. So if we were going to look at our class and the time they spent studying for the final and then their corresponding grade on the final, each student would have one data point, but each data point is made out of 2 items: time spent studying, corresponding grade on the final. Okay. Now, scatter plots are then used to determine whether 2 quantities are related. So, is there a correlation between the time spent studying and a corresponding grade on a final? Is there a correlation between the weight of a food item and the number of calories in that food item? Is there a corresponding relationship between age and blood pressure? So, is there some kind of relationship between these 2 data items that make up each data point? Okay, so that's what a scatter plot is used for. If there is a clear relationship, we say the data points are correlated. Okay, now I know using these little note sets that I have here, it's nice for me because I don't have to do as much writing. If you need to catch up on the writing, keep in mind, just hit pause, okay? And hopefully Winnie will behave herself, okay? Because she is definitely in here with me. All right, now moving forward, where did I put the mouse? Here it is. Okay, moving forward, we have some examples of data. So at some point in this class, we've talked about linear data. We talked very briefly about exponential data and logarithmic data, and we've talked a good bit about stuff that's quadratic. So when you're dealing with actual real world data sets, you're rarely going to have data that is exactly linear, exactly quadratic, exactly logarithmic, exactly exponential. Instead, you would have data points that hover really closely to a line, or hover around a parabola, or hover around the graph of a logarithmic function or an exponential function. So here we have 4 examples. So if we look at this first example of linear data, you can see clearly these points are not exactly on a line, but if I were to draw a line, all of those points are hovering really closely to it. Okay, for the next example, we have quadratic data. These data points are not exactly on a parabola, but if I were to draw a parabola, all of those data points are pretty close. Okay, same thing down here. These data points are not exactly logarithmic, but they're pretty close. And then lastly, these data points are not exactly exponential, but again, they're pretty close. Okay. So that's what's going to happen. These scatter plots are a visual way to see if data points have some kind of correlation or some kind of relationship. Is the relationship potentially linear? If so, points would be hovering around a line. If is the relationship potentially quadratic? If so, the points would be hovering around a parabola and so forth. So that's kind of the point of the scatter plot. It gives us a way to visually see if there's some kind of connection or some kind of relationship within our data points. Okay, we will then talk about linear correlation. So in this section, we're only going to focus on data that has a linear relationship. Okay, and the very first thing we have to talk about is something called the correlation coefficient. I have a typo. There we go. So the correlation coefficient is a number that basically tells us how linear is our data set. Okay. Is it super linear? Is it sort of linear? Where are we at with that connection? Okay. The more linear your data, the better your correlation coefficient is going to be. And there's some information about the correlation coefficient that I need to share with you. First of all, the correlation coefficient is denoted with a lowercase r. Luckily, this is something that we can get on the calculator. We will have to do a little setup on our calculator to get it to show us the correlation coefficient, but the calculator will calculate this. And you'll be thankful when you see a formula for it because the formula is bananas, okay? The correlation coefficient, again, denoted R, measures, it's a measure that describes the strength and direction of the relationship between variables whose data points lie on or near a line, okay? So basically, if R is positive, data has a positive slope. So that means as one variable gets bigger, the other variable also gets bigger. Okay, so think stuff going uphill. You kind of have to channel yourself from before the storm, and we were in chapter 7. Positive R means there's a positive slope. If R is negative, data has a negative. Whoops, I forgot the word slope. A negative slope. Let me fix this right here. Now, if you have a negative slope, that means as x gets bigger, y gets, or as x gets bigger, y gets smaller. Okay, so things are kind of going downhill. So the sign on R indicates positive or negative slope, positive or negative correlation. Okay, it doesn't mean anything as far as like our typical numerical numbers. It just tells us the direction of the relationship. Okay, values of R close to 1 or negative 1 indicate a strong. It'd be cool if I could spell, huh? Indicate a strong relationship. And then values of R close to 0, either positive or negative. If you're close to 0, this indicates a weak relationship. And luckily, we have some visuals that are coming up next. So some things about the correlation coefficient. It is a number. It's a measure that describes the strength and the direction. So this right here is important, strength and direction. Okay, so this direction is whether it's positive or negative. Winnie June, stop it. It's whether it's positive or negative, and then the strength is whether it's close to 1 or 0. Okay, and then the value for R, again, if it's positive, that tells you have kind of like a positive slope. If it's negative, it's telling you have kind of like a negative slope. And then values of R close to 1 or negative 1 indicate strong relationships. Values of R close to 0 represent a very weak relationship. Okay, so let's see what these look like. Whoops. All right, so this is directly from your book. Okay, so if you would rather go to your ebook and look at it there, you're welcome to do that. But what I want to note, I want you all to notice is notice the scatter plot and notice the corresponding R that is listed. So if you look at this first picture, these data points are exactly on a line. 100% they're on a line and they are going uphill. And if you'll notice, R is positive 1. That tells us there is a perfect positive correlation. That means those points are exactly on a line. okay? If we look at the next picture, you can see these points are not on a line, but they're hovering really, really closely to a line, okay? They're going uphill. That would tell us that R automatically is going to be positive, and it should be a value that's pretty close to 1. So if you look here, R is approximately 0.8. This indicates a strong positive correlation, okay? Now, if you look at this third picture, there's definitely something semi-linear going on. Those points are kind of hovering around a line, not very closely, but they're hovering around a line, sort of. They're just not nearly as compact. The data points are clearly going uphill. That means as x gets bigger, so does y. So we would expect a positive R value. In this case, we have an R of approximately 0.3. This indicates a moderate to weak positive correlation, okay? The fourth picture, we can draw a line through this data, but there are more data points away from the line than there are on the line. These data points are not hovering around this line in the slightest. You could draw any kind of shape in here and you're not going to get any kind of correlation. In this case, R is 0. There is no correlation, okay? So if R is exactly 1, you have a perfect correlation. If R is exactly 0, you have absolutely no correlation. And then otherwise, you're going to have something in between, okay? Now for this fifth image, if you look here, it looks like we have a line. The line is definitely going to have a negative slope. Those data points, as x gets bigger, y gets smaller. All right. The data points are not super compact around a line, but there's definitely something sort of linear happening here. Because the line is going downhill, we would expect a negative value for r. Here they say r is approximately negative 0.3. That would indicate a moderate to weak negative correlation, okay? And again, the negative correlation just means the data items would have like a negative slope. If you were to draw a line through it, the line would have that negative slope. All right, the sixth picture here, again, you can see we definitely have something linear happening. If I were to draw a line through these data points, you can see that that line would have a negative slope. While the data points are not exactly on the line, they are pretty compact about the line. There is definitely a pretty strong correlation here. So because the line would have a negative slope, we would have a negative value for R. Here we would say R is approximately negative 0.8. That indicates a strong negative correlation in your data set. And then finally, for the seventh picture, you can see these data points are exactly on a line. All right. We have a negative slope on this line. So that would tell me there's a negative correlation. And because those points are all exactly on the line, we should get an R of exactly -1. And that again indicates a perfect negative correlation. So again, the positive or negative value for R indicates if the data values are going uphill or downhill, if we want to just get down to like layman's terms. All right. So the reason we want to make sure we know how to do this on a calculator is because here, let me outline it in red. Here is the formula for the correlation coefficient. I wouldn't want to do that. In fact, I can say as a somewhat tenured math instructor, tenured just meaning I've been doing this forever, I've never done this by hand and I don't intend to during the rest of my career. I could, it would be a pain in the behind. So why not just use the calculator? Okay, so we will do this on the calculator. All right. So you don't have to worry about memorizing the formula at all. Please don't even try. You don't even have to worry about using the formula. We're for sure just going to use the calculator. Okay. Now, one more thing before we kind of dive into the next step. So notice here we have all of these lines. Okay. I drew these lines. This leads us to something called the line of best fit. Or the regression line. Okay, so this is the equation of the line that best represents the data set. Okay, so we have the line of best fit or the regression line. It is the equation of the line that best represents that data set. Okay, R tells us how good this equation is at making predictions about the data set. Okay, so let's say I take 100 students. I ask them, how much time did you spend studying for your math final? And then I go and figure out what their math final exam grade was. Okay, I then create a scatter plot that shows the time spent studying and the final exam score. Okay, I look at it and I say, hey, it looks like there's some kind of positive relationship. There's some kind of correlation between time and grade. The more time you spend studying, ideally, the higher your grade should be. Okay, so what I want to do then is I want to find an equation that best matches that data set. That's what this line of best fit is. I can then use that line or that equation to make assumptions or predictions about the data set. So I can say, okay, this equation best models this data. So assuming a student spent X amount of time studying, what could we predict or what could we expect their grade to be? Doesn't mean that's exactly what their grade is going to be, but it means given this data set, if we input a time, we can output an expected grade. Okay. Same thing with the weight of food and calories. There's an example we'll look at, I think, in this set of notes on candy bars. Does the weight of the candy bar have some kind of correlation with the calories in the candy bar? So let's say we collect the weight and calories on bunches and bunches of different candy bars. We make a scatter plot. We're like, yeah, there definitely does appear to be some kind of linear correlation. It seems that as the weight increases, so does the calorie count. So then we create the equation for the line that best represents that data, and then we can make predictions. We could say, okay, if a candy bar weighs this much, we could expect the calories to be about this. Again, it doesn't mean that's going to be the exact calorie count. It just means we should be somewhere in the ballpark of a correct calorie count. Okay, so moving on, we now have the equation for the line of best fit. And once again, I do not under any circumstances expect you to use this formula. Now, luckily, the line of best fit's a little bit less cumbersome than the correlation coefficient. But again, we can do this completely on the calculator, and that is going to be our focus, okay? So we have we have 3 examples that we're going to look at, all right? And first, we have to work with stuff on the calculator. So hold tight, got to deal with my dog. I'll be right back. All right, Winnie June, can you go and play somewhere else? Come on, let's get your toys. Come on, come on. You're such a good girl. Go play. Okay, I'm sort of back. My dog definitely wants to play, so this may not be the best video ever, but we're gonna try. Hey, sweet girl, you want to say hi? Do you want to say hi to everybody? Come here. Come here. You want to say hi? I can't lift you. You're too big. Here. Say hello. Can you say hi? Tell everybody hello. Good luck on your finals. Okay, now go play. Okay, so you met Winnie. She's a big girl. Alrighty, so if you haven't already, get your calculator out. If you do not have a graphing calculator, get a graphing calculator app. Okay. You can certainly use the graphing calculator apps. Just try to get the TI-84 and get one that you don't have to pay for. Okay. With that said, let's mosey on over to the calculator. Okay. The very first thing that we have to do is we have to tell our calculator to calculate the correlation coefficient. It does not automatically do this, okay? So there are several, well, I don't want to say several. There's a couple of ways you can do this. We're going to do it kind of the more just generic way, but we have this thing called a diagnostic on the calculator. It is not by default on. We need to turn it on. So what I want to do is if you look down here at the 0 button, it says catalog. I want to go to the catalog of functions, and we're just going to scroll until we find diagnostic on. There's a shortcut. It's more it's more complicated to explain than it is just to scroll, so we're just going to scroll. So we're going to go second catalog. It's going to pull up the catalog of all the functions on the calculator, and we're going to scroll down until we get to diagnostic on. Pause this video as you need to, rewind as you need to. So second catalog, and then we're going to scroll until we get to diagnostic on. Almost. All right, diagnostic off. We don't want it off. We want it on. So you go to diagnostic on, hit enter, and it's going to prompt you. It's going to be like, are you sure? You're going to hit enter again, and it should say done. That's all you have to do. You do not have to do this over and over again. You just do it the one time, and now your calculator is set to calculate the correlation coefficient. Okay? So with that said, let's go back to the worksheet. Is this the worksheet? There it is. Okay, we're going to look at this scatter plot. We're going to create a scatter plot. We're going to decide if there's some correlation or not. Okay, that's all we're going to do on this one. And then we'll type in, we'll figure out the actual regression line, but we're just going to look at R for this one. The next two examples will actually look more at the correlation coefficient. Okay, so if we wanted to, we could graph this by hand, but I want to show you how to do this on your calculator. So write these numbers down somewhere, make note of X and Y, all right, get it written down in front of you, and then we'll go back over to the calculator. Okay, so do you remember in the last video that I made, well, not the last one, but it would have been the one on measures of dispersion. We talked about this. So you want to go to this stat button, okay? This stat button allows you to input data, okay? Now remember, there are three menus under stat. There's edit, calc, and tests. We want to edit. We want to input some data. Okay, so under the edit menu, the first option is edit. You can either hit enter or type in a 1. All right. Now, ideally, you don't want any data to already be in here. If you were using your calculator for one of the previous sections, there could be some data in there. So all you would do is you would scroll up until L1 or L2 or whatever is highlighted. Hit the clear button. You want to clear the contents. And then once you hit the down arrow, that data disappears. Okay. Now to input this data set, L1 is going to be the X's and L2 is going to be the Y's. So remember, we had that table of values and we had that X was 1, X was 6, and then 4, and then 3, and then 7, and then 2. So type in all of your X values, and then just use this little directional circle, go over to the right until you're in the L2 column, and then type in the Y's. You have to type in corresponding ones. They have to match up. So whatever your X was, make sure you type the corresponding Y in for that, and don't change the order of these. So whatever X was, Y has to match, okay? So in this case, when X was 1, Y was 2. When X was 6, Y was 5. When X was 4, Y was 3. When X was 3, Y was 3. When X was 7, Y was 4. And when X was 2, Y was 1. Okay. So we've input the data. Now the big issue is, how do I look at the data? I want the scatter plot. And luckily, with a little bit of work, your calculator will create a scatter plot. Okay. So the first thing I want you to do is just go to the Y equals button. Okay. When you go to the Y equals button, up here you have plot 1, plot 2, plot 3. Notice they're not highlighted on my calculator. I want to turn plot 1 on. So I can just go up and then hit enter, and it has plot 1 on. That is one way to do this. Okay, you can just go to Y equals, turn plot 1 on. If I want to turn it off, I go up to plot 1, I hit enter, and I scroll back down. Okay, I want it on, so I would keep it highlighted. Now, the other way you could do this is, let's say you were in that stat screen again. Instead of just going to Y equals, notice if you look at the Y equals button, it says stat plot. Okay. Instead of hitting Y equals, I could go second Y equals, and it takes me to that screen. You can see here that I have plot 1 on, but it gives you more information. Okay. So I'm going to hit enter for plot 1. It tells you the type of graph that you're going to get. So we're just going to get a scatter plot. That's what those dots are. It tells you that the X's need to be in L1. The Y's need to be in L2. And this calculator has different colors, and then it has different shapes you can use to plot your points. Either way, you could, if you wanted to turn it off, instead of having it on, I would go over to off and hit enter, but I want to keep it on. All right. So again, from the stat screen, I could just go to Y equals and then go up until plot 1 is highlighted, and then hit enter, and that turns it on or off. We want it to stay highlighted to be on. Or from the stat screen, I could go second y equals. This allows me to turn plot one on, and it allows me to change the features. So I could change the type of graph, but don't. We want it to be a scatter plot. We want our x's in L1, our y's in L2, and we've got it marked as blue with these little like kind of circle dots, okay? So do that first. Make sure your stat is, or your stat plot is on. So plot one needs to be on. Okay, so we're back to this data set. Now what? Well, you would think, let's graph it. Okay, so let's graph it. And there you see some points. Okay, now this particular data set had 1, 2, 3, 4, 5, 6 points. You can see all 6 of our points here. Okay, in an example later on, we're going to have to tweak this a little bit. But for now, you can see your points. So you can see right here, they're not like exactly linear. But if I were to draw a line, I would have a line that goes through these data points like right here. Okay, so there's definitely a pretty strong linear correlation here. Okay, so we've input the data, we've turned our plot on, we've looked at the scatter plot. Now we can have the calculator calculate R for us, so we can get an actual number or a measure that tells us what the correlation is. So let's go back to stat. We're going to go over to calc. Okay, remember from last time, you have these 3 menus. There's edit, calc, test. We want to go to calc. And what we want to do is we want to go to option 4. Make sure it's option 4. LinReg for linear regression, and we want AX plus B. So we're going to go to option 4. We're going to verify that our X's are in L1, our Y's are in L2. Don't worry about this other stuff. We're just going to scroll down until we get to calculate and then hit enter. Now, what you're seeing here is information that does give you the line of best fit, but what our focus is going to be is R. Do not worry about R square. Honestly, I don't even remember what R square is. We're looking at just plain old R, and it is 0.85. Let's go 2 decimal places here. So R is 0.85, and if we go back to the worksheet, all right, so we have at this point, we had kind of a graph that looks sort of like this. All right, we could see that there was, probably some kind of a line that went through it. But most importantly, we found on the calculator that R was 0.85. And if we go up to those pictures that we looked at before, looking at this one right here, we definitely had some kind of positive correlation from the graph that we saw on the calculator. Those data points were definitely going uphill. They were not exactly on a line by any stretch, but they were pretty close. And we have here that R indicates a strong positive correlation when R is something like 0.8, or in our case, 0.85. So we would say here that there is a strong positive correlation between X and Y. So that's how you find R, and that's kind of how you would interpret your R. If you look at your data items, and this is really just thrown together, this doesn't necessarily represent this data set, but when you look at your data items right here, they seem to hover pretty closely around the line. Okay, and we have an R that backs that up. R was positive 0.8. That indicates a strong positive correlation. All right, so next up, let's look at this example here. So this example says the data models the number of hours students spent playing video games each week to the cumulative grade point average. Okay, so basically we're looking at the number of hours spent playing video games, and we compared that to the GPA, the grade point average. Now, in theory, we would assume that the more time a student spends on video games, the less time they're spending studying. So we would assume that less time video games, higher GPA, more time on video games, lower GPA. But let's see what the data says, okay? So make sure you have this written down somewhere. Pause the video to get it written down. And then what we're going to do is we're going to go back to the calculator. We're going to input the data. We're going to look at the scatter plot, and then we're going to go ahead and find the correlation coefficient, and we're going to find the line of best fit, okay? So if you look down here, just really quick, we're going to do parts A and B first, then we'll come back and do part C. So pause the video, get this stuff written down, and then we're going to go to the calculator. Excuse me. All right, so back to the calculator. Gotta get my Diet Coke. All right, back to the calculator. we want to go back to stat. We want to edit a list. So we're going to do the very first option that pops up. All right. I want to clear out the old data. I'm not going to try to type over it. I just want to clear it out. So I'm going to hit the up arrow until L1 and L2 are highlighted, and then hit clear. You want to clear the contents. Go down, they disappear. So do that for both columns. Go up until L1 or L2 is highlighted, hit clear, go down, everything is gone. And then we want to type in our new data items. Now, you should have the hours of video games per week. Generally speaking, time is going to be X. The other variable or the other thing being considered is going to be your Y. So for my X's, we have 0, 0, 2, 3, 3, 5, 8, 8, 10, and 12. Let me double check to make sure I typed it in. So 0, 0, 2, 3, 3, 5, 8, 8, 10, and hit enter, 12. Okay, so that's the hours spent each week for a student playing video games. We want to hit the right arrow in this little circle of direction stuff. Hit the right arrow and then type in the corresponding GPA. So the first 0 corresponds to a 3.49 GPA. The second 0 corresponds to a 3.05 GPA. Then we have 3.24, 2.82, 3.19, 2.78, 2.31, 2.54, 2.03, and 2.51. All right. Make sure you typed everything in correctly. So I'm really quickly going to go back through, make sure I typed them in. So I have 3.49, 3.05, 3.24, 2.82, 3.19, 2.78, 2.31, 2.54, 2.03. Okay, 2.51. So I think I've got mine typed in correctly. Make sure you get yours typed in. And then the first thing we want to do is we want to look at the scatter plot. Now we've already turned the plot on. It's on. It's not going to go away until we turn it off. So what I want to do is I want to go to graph. Now, you can see here that this kind of goes off the screen a little bit. We want to make sure we're seeing every single data point, okay? So at this point, it does look like there's a negative correlation. That means as X gets bigger, the Y grade seems to get a little bit lower. So X being the time spent studying, it does seem to indicate that the more time spent on video games, the lower the GPA. But let's make sure we see all of the data points. And here's how. You can manually tweak your window, okay? Or if you go to this top row of buttons and go to zoom, click zoom, and it's going to give you all the different ways that you can zoom. We want to zoom stat. What this does is it zooms into the data that you've got in that stat screen, that stat button, like all the data you have collected there. It's going to zoom into that data. So you can either scroll down until 9 is highlighted or just type in the 9 button, and look, it zooms right into where our data is. So again, you can kind of imagine excuse me, you can kind of imagine a line going from here to here. So these data points, while they're not exactly on a line, there does seem to be a correlation with time spent on video games and corresponding GPA. Now, of course, there's other stuff that impacts GPA, but it does seem like there's a negative impact with the hours spent playing video games. As video gaming increases, GPA tends to go down, okay? So we've looked at the scatter plot. Now what we want to do, sorry, this has been a lot of talking today. Now what we want to do is we want to get the calculator to calculate the correlation coefficient and the equation for the line of best fit, okay? So we want to go back to stat. We want to go over to the calculate menu. So we're going to hit the right arrow once. We want to go to ln reg ax plus b. Make sure you do option 4, okay? My x's were in L1. My y's were in L2. So just make sure those two match and then just hit enter until this comes up. Now, let's say we go to the nearest hundredth. So we're going to go 2 decimal places. So I'm going to make note of a few things. First of all, notice the first thing they tell you is y equals ax plus b. That's the form of our line. So this is going to give us a line that's in slope intercept form, okay? A, they're going to give you next, and they give you this crazy decimal. We're going to round this usually to 2 or 3 decimal places. I think I want to go just 2 decimal places right now. So A is negative 0.09. They then tell you what B is. Remember, A is the slope. We usually call it M. For some reason, the calculator calls it A. And then B is the y-intercept. So in this case, the y-intercept is, we're going to go 3.28 if we round. So 3.28. And then R, don't worry about R squared, just plain old R, is negative 0.87 if we round. Okay, so pause the video. Make sure you get that stuff written down. You can completely ignore R squared, but the other stuff, write it down and round to 2 decimal places. And let's go back to the worksheet. Okay, so what we found was that the form of our line is going to be y equals ax plus b. This is the same as y equals mx plus b, which is slope, intercept form, where m is the slope and b is the y-intercept. And that is a b, not a 6. And this is. Okay. So basically we have the same thing here. They're just using a instead of m. And then we're told that a is negative 0.09 if we round to 2 decimal places. Okay. B was 3.28 if we round to 2 decimal places. And then R we got as negative 0.87. So now we can answer the questions about this problem. So the first question says, use the data to find the correlation coefficient rounded to 2 decimal places. Well, R was negative 0.87. This tells us there is a strong negative correlation between time playing video games and GPA, meaning that the more time you spend playing video games, the lower your GPA is going to be. So I'll try to fit that in here. More time playing video games means a lower GPA. And it's a pretty strong correlation. There's evidence in this table that you probably want to spend less time playing video games if you want the higher GPA. This is not necessarily real world, but according to this table, that's the case. Now, the next thing we want to get is the equation for the regression line. So basically what we want to do, let me scroll back up a little bit. We want to take these 2 values right here, okay? And we want to plug them into that template for the equation for the regression line, okay? So what we're going to get is y equals negative 0.09x plus 3.28. So we have here that the slope is negative 0.09 and the y-intercept is 3.28. Okay. So there you have it. That's the first part. You want to find your scatter plot. So take your data, plot it into a scatter plot, kind of get a visual. Does there appear to be some kind of correlation or not? And then back it up with numbers. Let the calculator calculate the correlation coefficient. We have R is negative 0.87. And then we have the equation of the regression line, and it is y equals negative 0.09x plus 3.28. Now, what we can do is we can use this equation to make predictions or assumptions. It's not going to fit about this data set. All right, so it says use the regression equation to predict the GPA of a student who plays 15 hours of video games per week. So video games, well, let me change that to hours playing video games. So hours playing video games is X, GPA is Y. So we get Y equals negative 0.09. We're going to try to predict the GPA for a student who spends 15 hours a week. So we're going to plug in 15 for X. And then we can go back to the calculator really quickly. All right. So we had negative 0.09, whoops, times 15 plus 3.28, and we get 1.93, okay? So we get that Y equals 1.93. So we could expect a GPA of around 1.93 for a student who spent 15 hours a week playing video games. It doesn't mean a student who spends exactly 15 hours a week is going to have exactly a 1.9 GPA. This is all kind of predictions based on data that we've already looked at, okay? So again, pause, rewind, go back and double check things if you need to. But for now, let's look at our next example. Okay. So the last example for this data or this set of notes is the following data represents the weight in grams of various candy bars and the corresponding number of calories. So we have different candy bars. So we have Hershey's Milk Chocolate, Nestle Crunch, Butterfinger, Baby Ruth, Almond Joy, Twix, Snickers, and Heath. I do not know if this data is accurate. I cannot imagine just making this up for this problem. But again, this may not be fact. All right, just know that. We have the corresponding weight in grams. We're going to let the corresponding weight or the corresponding, we want the weight to be the X, and we're going to let the corresponding calories be the Y. Okay, so make sure you write this down, and then we're going to scoot over to the calculator. So write this down, get it in your notes, pause the video if necessary, and let's go to the calculator. All right. So just like the previous examples, we want to go to stat. I want to edit a list, so I'm going to hit enter. So under the edit menu, you want option 1, hit enter. I don't want to worry about typing over. I'm just going to go ahead and clear out the data. So I'm going to go up to L1 and L2. When they're highlighted, I'm going to hit clear. It doesn't look like anything happens until you go back down. All right, do that for both L1 and L2. All right, so for L1, we're going to type in our X values, okay? So X is going to be the weight. So I have 44.28. I have 44.84, 61.3, 66.45, 47.33, 58, 61.12, and 39.52. So I'm going to double check really quick, make sure I got my X's correct. So 44.28, 44.84, 61.3, 66.45, 47.33, 58, 61.12, 39.52. I think my X's are good, so I'm going to hit the right arrow. I'm going to go to the Y's, and I'm going to then type in the calories. And you have to make sure they match. So whichever X, make sure you get the correct Y. So for the first X, I have 230 for Y. Second X is 230. Next, I have 270. Then 280. 220. 280. 280 again. And 210. And definitely check, double check, make sure you typed everything in correctly. All right, so I think I'm good. So the first thing I want to do is I want to look at the scatter plot. I want to kind of get a visual idea, a kind of just a general understanding of what this data set is doing. So I want to go to graph. Now, if we go to graph, it's going to have the previous zoom feature for the old data set. It's not going to be accurate for this data set again. So we can go zoom stat, which is zoom 9. And there you can see our data set. So it does appear that as X, the weight increases, so does the calorie count. There appears to be a strong positive correlation. Okay. Now, before we move on, I want to show you how to get your calculator back to the default, okay? So if you go back to the Zoom screen and you go to Zoom standard, it's going to take you back to like the factory default, which is on the x-axis, you go negative to positive 10, and then on the y-axis, you go negative to positive 10. So if we go Zoom standard, which is option 6, it goes back to the default, okay? If you go Zoom 9, which is Zoom stat, it takes you back to the stat screen. So make sure you understand how to go back and forth. So again, Zoom standard takes you back to the default. Zoom option 9, which is Zoom stat, takes you back to this data set. Okay, so just understand how to flip back and forth. Okay, so right here, again, it looks like there's a strong positive correlation between weight and calorie count for these candy bars. Okay, so now let's calculate. Let's figure out R, and we're going to figure out the equation for the line of best fit. And I think going 2 decimal places again makes sense. So let's go stat. We're going to go over to calculate. Again, we want ln reg ax plus b. Make sure you choose option 4. My x's are in L1, my y's are in L2. So hit enter, enter, enter until it pops up your information. Alrighty, let me write this down. So again, we're using y equals ax plus b. We are told that a is, let's go 2 decimal places. So a is 2.88. B is 97 point, if we round, 59. Completely disregard R squared. And then R is 0.95 with rounding. Okay, so pause the screen, get that stuff written down. And now let's go back to the worksheet. Okay, so we have, remember, y equals ax plus b. And we were told that a is 2.88 with rounding. B is 97.59 with rounding. And then I think question A is probably something about the correlation coefficient. So it says here, what type of relation appears to exist between the weight of a candy bar and the number of calories? So for this one, let's just write out what we think happens, okay? I would say something like there appears to be a strong positive correlation. This means as the weight in grams increases, so does the calorie count. So that's just kind of verbally what we saw from the scatter plot. We definitely saw as the X got bigger, so did the Y. There was a strong positive correlation between weight and calories, okay? Now we want to back that up with the correlation coefficient. So R, the correlation coefficient when we rounded, was 0.95, and this backs up the statement in part A. So if we go back to those original scatter plots right here, when we had a perfect correlation, we had a correlation coefficient of 1. That was a perfect positive correlation. And then we had R is 0.08. Data points were close to the line, but not exactly on the line. We're somewhere in between this first and second graph. We have a strong correlation. That means we're pretty much guaranteed as X increases, so does Y. Okay, so this correlation coefficient of 0.95, it does back up the statement that as the weight increases, so does the calorie count. Okay, now next up, we have the equation for the line of best fit. All right, so remember, we have Y equals AX plus B. When we rounded, we got A was 2.88. We had that B was 97.59. So we get Y equals 2.88x plus 97.59. I do want to remind you that this is M equals the slope, and this is the Y-intercept, okay? Now, the last part is use the regression equation to predict the number of calories in a candy bar that weighs 100 grams. Okay, now remember, these are just predictions. They're not going to be exact. It's just based on this data, this is what we could expect to happen. Okay, so we have a situation where we have a weight So remember, weight is X. We want to determine the number of calories Y. So I'm going to take the equation from part C. Y equals 2.88. I'm going to replace X, the weight, with 100 grams. And then I'm going to add 97.59. Write that down. Pause if you need to. And then we can go back to the calculator. So we had 2.88 times 100. And then we want to add 97.59. And we get 385.59. Let's go ahead and round, and let's say this is 386. Okay. So 386. So we get here that Y is approximately 386 calories. In words, that means if a candy bar weighs 100 grams, we could expect, it doesn't mean it's going to be exact, this is just something that we could expect. We could expect the calories to be approximately 386. Again, that doesn't mean if a candy bar weighs exactly 100 grams, the calories will be exactly 386 calories. It just means it's going to be somewhere in that ballpark, okay? Based on this data set with our correlation coefficient, we've got a pretty good understanding of weight of candy bars and corresponding calorie count, okay? So that is it for this section of your notes. This is the last one for the book. So it covers, again, scatter plot, correlation coefficient, and regression. You do need to have a graphing calculator. I highly recommend the TI-84. Look for an app on your phone if you do not have one of your own. So look for an app on your phone that you do not have to play with. I will make a video showing you how to get to the calculator I used, and I'll post it separately. All right, take care.